All right, so I believe today is episode 9. Um, I need to work on an intro because I'm kind of just rambling off the top of my head. But today we will be, damn, I should practice like an intro. What should I say? I'm gonna keep this shit in the clip because this is just raw and filtered. I don't do no editing. Um, anyways, yeah. Dive straight in. You already know what the deal is, what the verdict is. All right, so we have two. Input array is sorted. All right, given a one indexed array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers index 1 and numbers index 2, where 1 is less than or equal to index 1 is less than index 2 is less than or equal to numbers dot length. Okay, that's a lot. um We have a one indexed array of integers. Okay, return the indices of the two numbers index 1 and index 2 added by 1 as an integer array index 1, index 2 of a length 2. The tests are generated such that there is exactly one solution. You may not use the same element twice. Your solution must constant, only use constant extra. Okay, I don't even know what that means. Constant extra space. Um, I had to, I had to cover up like the left side of the screen, the little side bar shit. All right, so let's look at some examples. So numbers equals 2, 7, 11, and 15. Our target is 9. The output is 1 and 2 because 1 plus 2 equals 9. The sum of 2 and 7 is 9. Therefore, index 1, index 2, we return 1 and 2. Okay, so it's one index. So we're not returning 0 and 1. We're returning 1 and 2. That's what that means. All right, now our target is 6. So we would return 1 and 3. The sum of 2 and 4 is 6. Therefore, index 1 equals 1 and index 2 equals 3. We return 1 and 3. That makes sense. Okay, so we're finding two points in the array where we get the target value. All right. Now, going based off of common sense, we know that our problem set is sorted by types of solutions. For this specific problem, we know that it is a two-pointer approach. Um, yeah, so we'll do int L equals 0, int R equals numbers dot size minus 1. All right, so using a two-pointer approach, we can do a for loop or a while loop. So for this, okay, I should probably be writing pseudocode just for like interview practice sake. Um, yeah, so we're gonna do a two-pointer approach. Also, just to like reinstate this, I usually don't program or code through my Windows desktop. I usually do everything directly through my Mac OS laptop, and the keyboard is a lot more compact. This is a bigger keyboard, and also I have to hold FN whenever I'm using like arrow keys. So I have to hold the key and then hit the arrows for them to like trigger. So it's like a little bit of a constraint, a little bit of a bottleneck whenever I do code on my Windows. That's why I type slower and I have to look down constantly. Also, my mic is like right. It's like, so I'm typing like this, and my mic is like right in between, if that makes sense. So I have to like go around it. And it's, anyways, yeah. So we're doing a two-pointer approach. So a while loop or a for loop. I'm gonna just use a for loop for like simplicity. Same shit, I guess. For int I equals 0, I less than numbers dot size I plus plus. Okay, so we have our for loop, and we need to get target. So the way the two-pointer approach works, I think I have to use a while loop for two-pointer approach. Now that I think about it, I think I do. Yeah. Okay, so while uh L is less than R. I don't know if it's less than or equal to or just less than, but we'll figure that out. So we'll do while L is less than R, we'll do if numbers of L plus numbers of R equals target. We're returning indexes. So return L plus 1 comma R plus 1. All right. So if these two amounts equal our target, then we return the index plus 1 because it's one indexed. If they don't, we check if numbers of L. I can just do this shit again. I'm not gonna lie. I hate typing on this keyboard. Okay, so we do this, and instead of that, we'll do is greater than the target. We'll do if it's greater, it's sorted, right? That's a key point. It says the input array is sorted. So we know that if it's greater than target, we have to decrement our R value. So we'll do R minus minus, and then we'll do if it's less, then we'll do L plus plus. And so this should return that. For like edge case sake, we can just do return. Oh, we're returning a vector of integers. Okay, so we can't just do it. Well, can we? Does this count as like a vector? I don't fucking know. All right, yeah, it's fine. We'll see. We'll just do return. All right, so in theory, this should work, maybe. Maybe my syntax is off. Okay, so we'll return like just this, which is an empty vector, right? I think the brackets count as like an empty vector. Okay, boom. So we'll submit that. Bro, that shit took like 2 seconds. Twosome has always been like some easy shit anyways. All right, I beat 100% of people, so this shit was easy. Go ahead and it's like my first one that I've done. And yesterday we attempted group anagrams, so today we got to reattempt this one. And I only count it as a win if I can do it without using ChatGPT. So, all right, top K frequent elements. Okay, yeah, let me just reset this. I'm not looking. I'm not looking. I don't want any refreshers or anything because in the interview I'm not gonna have this. Okay, so given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Okay, so hash map problem. Um, so we're giving k and we have to return k most frequent elements. So my logic for this would be to have a counter for every digit and we're returning the most frequent. So we would use an unordered map as a counter for all the digits, and then we would order the digits by, I believe we use a lambda function to order them by not the key but the value, because the value is going to be our counter. And once we order them by the value, we put them in a vector. That makes sense. So like would return result. I like to reverse engineer sometimes. Would return result, and result would pretty much be would have an unordered map, and this would hold an integer to an integer. We'll call this counter, and then we'll do like for int. Wait, no, we'll just do for int num in nums. Then we'll do counter of num plus plus. And so our map gets filled with these values and their active count. Then we just sort by using the lambda function, but we can't actually sort an unordered map, so I'm pretty sure we have to put it in a vector of pairs. So we'll do vector pair int, and then we'll call this pairs. I believe this is the correct approach because, okay, so we're not, so whenever we push back, like, so for instance, uh, where are we? We'll do that, and then we'll do uh, counter, because you can't sort an unordered map, I don't believe. So we would have to like put in a vector of pairs, and then once we do this, we can do pairs dot push underscore back pairs 2. So this should push back our pairs 2, which is what we get from this. And now we have everything in our vector of pairs. And now we can finally sort it using the lambda function, which I don't remember the syntax for this function, but I know we compare A and B values. And so it would be, I know the body of it, like it return is like A dot second greater than B dot. It's something like this. It's something like this. And the actual like header for this would be, I don't remember the lambda function. Okay. ChatGPT. So I can't count this as a win. So we'll say lambda function for sorting vector of pairs in C++. Okay. So we have our vector of pairs right here. It would be sort the beginning to the end, and then we'd have, I believe this stands for, okay, what does mean? It's an empty array, right? Oh wait, in C++, in a C++ lambda, the bracket, open close bracket, or yeah, is called the capture list. It controls which variables from the surrounding scope are made available inside the lambda. Think of it like packing some outside variables into your mini furniture so it can use them. Packing outside variables into your mini function. I said furniture, function. Okay, outside variables. Captures nothing from outside the scope. Okay. So we don't need to capture anything from outside, but we have to include it, I assume. Okay. So we would use this, but with our elements, right? So it would be sort uh, pairs dot begin, comma, pairs dot end. And so we would have our sort, and then we would have another comma, and that would be the brackets, and then we would do this logic right here. Um, and then we would just return this, I believe, right? Okay, no, if A, okay, so we have more logic. So for sorting just this one, it would just be dot sec. Yeah, by ascending. Okay, so this is ascending, so it means it's getting bigger. By ascending, you mean smallest to largest. Okay, so we have to do reverse ascending order, which I have that logic in place right here. And so now that we have this, we know our vector of pairs is entirely sorted. So we'll do for auto and where are we? Ampersand. Um, we'll call this pairs 2 again. And then we'll do pairs. And so, oh wow, that's very incorrect. Sorry about that. All right, so now we do this. And we pretty much stick this into our result vector, which I have not defined. And so we do result dot push underscore back uh, pairs to dot second. And that should push back the values, I believe. We don't want the values, we want the key. We sorted by value, but we actually want the key, so it'd be first, right? Okay, I have a syntax error. And B. Okay, so we need a closing parenthesis. So the entire thing is the sort function. Wow, that's very interesting. Is it 2 at the end? It's 1. Okay. Okay. Yeah. This should run now. Wrong. Okay, why are we wrong? All right, so let's see our process here. Oh, K. Okay, we're not including K. So we'll have int K. Oh, we already have K. We'll do int I, and then we'll do I plus plus, and then we'll do if I equals K, then we break, and now it should run. I forgot about K. Wrong answer. Okay. Maybe sticking this before because we're still getting an extra number. My output is still using an extra number. Okay. I didn't initialize I. That's probably what it was. It should have like flagged me for not initializing I. Okay, perfect. Accepted. And if we submit, it should be up there. 100%. Yeah. Okay, so we just forgot to initialize I. We forgot the how to write the lambda function, and everything else was pretty good. I'm making good time. How long have I been? It's only been 20 minutes. Okay, yeah. So we're getting better at this. I'll probably revisit this one more time just to really nail this lambda function. So the syntax for this would be we use sort and then pairs dot. So this pretty much starts off like a regular sort function, and then we have like this these brackets right here, and then we do constant pair. We have a pair of integers, and we do ampersand a for like reference, and then we get another one which we define by reference as well, and then we just compare the two because we're doing dot second, and we don't want ascending order, we want descending order, so greatest to least. So yeah, it's just sticking this in front and then passing these by value, and that's our function. So I just pretty much have to recall how to do that. So looking away, our sort function would be sort. Okay, I don't really like how that's sort pairs dot begin, comma, pairs dot end, comma. This is pretty big. Can I zoom in? Pairs dot end. Oh wait, the fuck? Sorry. How do I move? Select. I don't want to. Um. Why can't I move? I'm clicking and I'm hitting the thing. This is brilliant, isn't it? Undo, undo, do 100. Okay, I guess this is fine. Whatever. So we'll do sort pairs dot begin uh comma pairs dot end comma again. That's still big. 8 pairs dot end. And then we have our brackets. Yo, why is the text white? Yo, this is actually kind of like, what is this? How is it not registering? Okay. We have our brackets, and then we have um pair int int, and then we call that a. Do the same thing. Can I do this? Yeah, I'm still learning the shortcuts here. B, go like that. Then we go like this. We do the fuck. Why did that go down so much? Alright, anyways. Does this, why is it behind? Why is it typing underneath? Yo, you see where my cursor is? Okay, what is going on? I guess I'll just one line this thing because obviously, okay, there it goes. So then we do return a dot second over b dot second, And then we close and do that. I'm pretty sure this return statement is also supposed to have one, but I'm not sure. Yeah. Okay. That's pretty much that logic. Where are we? All right. So I just gotta remember this, and then I should be good moving forward. And so tomorrow we'll hit up threesome. But yeah, so that's gonna be the end of this one. Damn, that didn't take that much time at all. I'm actually so happy because usually this shit would take like 30, 40 minutes. Or maybe we're at 30 now because that logic. But I had time to like process it because I already knew the logic and everything. But yeah, it's gonna be it for today. I'll see you guys tomorrow. And yeah, appreciate everybody for watching. Thank you.